Hi guys, it's Dr. Borthwick here again. Just thought you've done really well with the writing chemical formula for the first time in the last assignment. This assignment we're going to focus a little bit more on that because obviously it's one of the most important things about chemistry, and looking at a couple of other things. You will have noticed that sometimes transition metals, they can have various different valencies, so how do you know which ones there are? And there are other kind of formulas using that don't use valencies at all. Okay, so when you're going through this assignment, just take a note. That's learning outcomes there. But the first thing I'd like you to do, there is a quick quiz for you to do, and it's revision. It's things like mass number, the notation, atomic number, working out the protons, electrons, and neutrons. If we had been in class, we'd be doing that a lot. So, and then a little bit of revision here of writing formulas from the last assignment. This is on the worksheet, so it's exactly the same questions on the worksheet, so just go through them. And then the next thing is, right, so transition metals. Now, most of you will have come across something called Roman numerals. Roman numerals don't use 1, 2, 3, 4, they use I. So capital I, so 1 capital I is 1, 2 is 2, 3 is 3, 1V is 4, V is 5, VI is 6. So this tells you the valency of the metal in front of the Roman numerals. The Roman numerals are usually put in brackets, and then you have the compound name with the brackets and the Roman numerals in the middle. So magnesium here, 4 oxide. So how would you actually do magnesium? Write that formula out. Well, same idea as what you did before. You write out the formulas, or you do it by the arms. So imagine here you've got magnesium, or manganese, sorry, has a valency of 4. So there's going to be 4 arms coming out of it. You've got oxygen, which only has 2. So in order to fill these up, you need to have 2 oxygens. Oops. So you have manganese, 1 manganese, and you have 2 oxygens. Okay, that's manganese 4 oxide. Okay, that's how I worked that one out there. So there's one for you to do here. I'll pop the answer once I've finished making these slides on the next question, so you can try that. And then there's a load for you to try here. These are just for you to try at home, practice, see if you get the right answers. I'll skip the next slide because all the answers are on the next slide. And then we're going to move on to another group of compounds that don't use valencies at all. So you don't use valencies. I like to say that the valencies are thrown out the window, and you just need to use the names of what you see in front of you. So nitrogen dioxide, what have you got? Well, I've got 1 nitrogen and I've got 2 oxygens. So in order to write that formula, it would be nitrogen, oxygen. Oh, I've got 2 oxygens, I'll put 2 there. So similar here, carbon monoxide. So 1 carbon because there's nothing in front of it. Monoxide, what's mon mean? Oh, 1. So carbon monoxide. Carbon dioxide, 1C, 2 O's. Okay, so again, there's a question in the worksheet. Have a go at that. Now, we're going to be going on to compounds next time. There's 2 sets of compounds, things called covalent molecules and ionic compounds. Ionic compounds are made up of something called ions. So if you look at these slides, they're just basically showing you this is the fluorine atom. You know its electron arrangement is 2, then 7. Now, when it forms an ion, the whole point of forming an ion is to get a full outer shell. It's very easy for it just to gain 1 electron. If it gains an electron, you're going to have 1 more negative electron compared to the positive protons. So in fluorine, you have 9 positive protons. This guy here has 10 electrons. Therefore, it has this charge of minus. Now, there's a rule about metals and non-metals. All metals will form positive ions. All non-metals, like fluorine, will always form negative ions because they're gaining electrons. So when they gain electrons, they form a negative ion. Now, I'm introducing this just in this assignment. Don't worry, we will be talking about this again later. I'll find a new video as well for you to work on if that helps. Again, with sodium, sodium's a metal. So again, there's a sodium ion. Now, with metals, it's so much easier to just lose one electron rather than gaining 7. So in this case, it's just lost an electron. It's got one less electron compared to the number of protons. So there it is positive. Now, like all the writing formulas, you never put the 1 in, so it's just plus. Okay, so the last sort of bit on that worksheet is for you to just look at how many electrons would it take for fluorine to get a full outer shell? 1 electron. How many for beryllium to get a full outer shell? Well, actually, it's only got 2 in its outer shell, so much easier for 1, 2, don't worry about 4, 1, 2, and 3 to lose electrons, therefore become positive, put the number in front of the charge, and for non-metals to become negative because they're gaining electrons. Okay, so hopefully you'll be able to go through the worksheet. The questions are similar to this, but obviously the answers for those ones are in the next slide. But have a look, the worksheet questions are different. As usual, guys, please get in touch if you're having any problems about understanding what the work is. But I think most of you are getting on brilliantly. Okay, bye for now.